What's up, everybody? Welcome to Maths with Gaston. I am Gaston Mapala right here at Maths with Gaston. I hope you guys are having an amazing time and you are enjoying yourself on this channel while we do mathematics together. And this is helping you to prepare for that particular exam that you're about to write. Okay, now today let's have a look at question 3, November 2022, grade 12 maths paper 2. It was an analytical geometry question. Let's go ahead and read the question and let's see what it says. It says a triangle. Let's have a look at this triangle here. It says triangle TSK. Let's see, where are you? TSK. So we can see is the bigger triangle. There it is there. TSK is drawn. Okay, we see that. And then the equation of ST, this is the equation of ST, is given by y is equals to half x plus 6. Okay, great stuff. And ST cuts through the x-axis at point M. Here's point M here. And then W is given by that. Okay, lies on the ST, and then also R lies on SK. So here is R there, also lies on SK. Okay, and then they said such that WR is parallel to the y-axis, such that WR, there is WR there, it is parallel to the y-axis. Great stuff. Then parallel, gonna say something about the gradients and whatnot there. Okay, great stuff. And then WK cuts the x-axis at V. Okay, it is cutting the x-axis at V and the y-axis at point P. Where's P? Okay, here's point P here. Great stuff. We appreciate that. A lot of information on this line as well. KS produced cut. Where's the KS? Where's KS? Let's see. Where's KS? KS. K, here's K here. And therefore there is S cuts the x-axis at point N. Okay, here it is here. When it's cut here, it's giving us this angle of inclination there. It's giving us that angle there. Great stuff. Okay, and then they said angle on N, and then TSKN is angle theta, which is this angle right here. Okay, great stuff. So now let's go ahead and read the first question and see what we can do, guys. Please, I'll always advise that you read these questions more than once. If you didn't understand it, please go ahead and reread it nicely and then writing down what is written there. So let's go ahead and look at 3.1. 3.1, it says that calculate the gradient of WP. So WP, what are the coordinates of W? Do we have them? Yes, we do. 4 is to 4. Do we have the coordinates of P? Let's see here, coordinates of P. Do we have P? Yes, we do have 0. We do have coordinates of P is 0 is to negative 4. Okay, great stuff. So we all know the gradient formula right there from our formula sheet. Gradient, it's small letter m, WP, it's equal to the y at, let me see, the y at W minus the y at P, rather, minus the y at P all over x at W minus the x at P. Okay, so we are gonna go ahead and substitute here. The first coordinate that we have here, y at W, is 4 minus into minus the y at P all over x at W is negative 4. Therefore also minus 0 there. Okay, therefore the gradient of WP, because you guys are in grade 12, I'm just gonna go straight away to the answer here. The answer that we're getting is negative 2. Okay, great stuff then. All right, and then moving right along, let's come here now and say 3.2. Okay, we know the gradient of WP, this line here, and as expected the line is negative, so therefore they are asking us to calculate, show that WP. Now they are asking us to show that WP is perpendicular to ST. Okay, we already know this gradient here, so they've given us the equation of ST here, as a straight line there, so we need to show that this is perpendicular. Okay, so perpendicular is related to the gradient. From the basics, we know that the gradient of WP multiplied by the gradient of ST should give us -1. If they do, therefore they are perpendicular. If they don't, therefore they are not perpendicular. We already have the gradient of WP. Now let's come ahead and look for the gradient of ST. Gradient of ST, looking at the equation here, is equals to half. This is the gradient of ST. Okay, so gradient of ST is 1/2. So we are gonna come here and substitute back into this equation here to prove that they are perpendicular or not. Okay, so W, it's -2 multiplied by 1/2, which gives us -1. So you can come here and say, therefore, right hand, no, not right hand side. Starting from this is the left hand side is equal to the right hand side. Therefore, which means that this is the WP is perpendicular to ST. Interesting. Okay, great stuff. Now moving right along, let's move to 3.3. Okay, 3.3 is still the same question. 3.3, we already know the gradient here. The gradient here is given by M of WP is equals to -2. Great stuff. So 3.3 says if the equation of SK, where is SK? Here's the line here. The line SK, they're saying if the equation is given by 5y plus 2x plus 60 is equal to 0, calculate the coordinates of K. Coordinates of K. K would be here, which is the point of intersection between SK and also ST. All right, so let's come here, say 3.3, and we deal with this question. Okay, great stuff. Let's start with SK and simplify it. It's given by 5y. Then the only thing we need to do here is to make y the subject of the formula. X plus 60 is equal to 0. Then we are gonna make y the subject of the formula. We take everything that side, minus 2x minus 60. Therefore, we divide everything by 5. Divide everything by 5. We are gonna be left with y is equal to -2x over 5. -60 divided by 5 is going to give us -12. Okay. Great stuff. Okay, now for the equation of, let's move, we're moving right along. This is the equation of SK as given here. Now what are we looking for? We have got the equation of ST is given here. Okay, equation of ST as given here. Equation of ST is equal to half. Is it? Yeah, the equation of ST is equal to half x plus 6. Okay, great stuff. So now the only thing that we can do, we know that at point S, these equations are equal because it is the point of intersection between the two straight lines. So this is where they're intersecting here, guys. If you have a look at there it is here. I'm talking about these two lines. Let me just highlight them so that you guys can see exactly what I'm talking about. They intersect at point S there. Okay, so we are gonna equate the two equations. Okay, let's come here. SK, which is -1/5 minus 12, is equal to, let's see, I think this thing clearly is equal to 1/2x plus 6. Therefore, we are gonna make x the subject of the formula, therefore, and multiply throughout. But first thing first that we can do, we can see that there's a 5 there, then there's a 2 here. We can multiply throughout by 10 to avoid having a fraction there. So 10 times a -5/2 is going to give us -4x, and therefore 12 times 10, 120. is equals to half times 10 is going to give us 5x plus 6 times 10 is going to be 60. Therefore, we are going to take all the x's onto to the one side and then all the numbers to the one side. All right. So therefore, once we do that, we are going to have 9x is equal to 120 is going to be 120. When you take this one, that side is going to be 120 plus, excuse me, all right, so it's going to be the negative, then it's going to be 120 minus going to be minus 180 here, divided by 90 divided by 19. I hope you guys can follow the algebra there. Therefore, x is equals to negative 20. All right, so with that, and then we can sub this x in any of the equations that sub in any of the equations. I rather prefer let's sub it into equation of sk. So therefore, when we sub it into the equation of sk, what do we get? Where is the equation of sk? No, st rather. I'm saying sk, but I wrote st. St is going to be half, then minus 20 plus 6, giving us a y value of negative 4. Great stuff, guys. So now once you have that, you can come in and tell the examiner that therefore the values or the coordinates of sk is going to be negative 20 is to negative 4. Great stuff, which makes sense because x is negative here on this quadrant, and also y is also negative on that quadrant as well. All right, great stuff. So now with that, let's move right along. Quite an interesting question, guys. I mean, if you don't follow, please make sure that you drop a comment on the comment section below, and please let me know what can I do to improve better and also to explain better for you guys to understand these lessons. All right, okay, let's move on to 3.2. 3.2 says calculate the length of WR. Okay, yes, 3.4. We are calculating the length of WR. So this is the distance WR. Let's have a look at W is there. We've got coordinates. Where is R? R is here. We don't have coordinates of R. However, if you have a look at R here, where is sitting R? Let me just remove this line here because I think maybe you guys don't see clearly. Okay, there you go. So let me also remove this one here. So we are dealing with WR. So now, but if you see that R and W, they are sitting, they are sharing one x value here. So it means the coordinates of R, the x value at W is also the same as the x value at R, but we don't know the y value here. W, we know that it's minus 4 and is to 4, but we can get this R value. How can we get the R value? We can get the R value because we know the equation of this line here. We can substitute this minus 4 to get the y value. All right, I hope you guys understand. Okay, because we've got the equation of sk, which is given by 5y plus 2. Okay, no, why am I writing 20? Plus 2x plus 2x plus 60 is equal to 0. We know the x value here. We are looking for the y, so therefore we are going to put 5y plus, we know that we are looking for the x value, which is for the y value rather. Okay, plus 60 is equals to 0. So therefore what are we going to get here? After substituting everything here, we are going to get, wait a minute, okay, makes sense now, guys. I see what I did here. Okay, I'm writing a little bit different. Let me see here, how can we simplify this one? Let me grab my calculator quickly. All right, guys, please make sure that if you're new on this channel, make sure that you subscribe, and we'll do whatever it takes to assist you. If you would like for one-on-one, please make sure that you reach out to me, and then we can easily do one-on-one together with you. All right, so we have got negative 8. 2 times negative 4 is going to be negative 8 plus 60 is going to give us 52. So therefore we are going to have 5 here, 5y is equals to negative we're taking 52 to the other, negative 52, divide everything by 5, and therefore we should be able to get the coordinate of y thereof. Okay, so 52 divided by 5 is giving us 52, negative 52 over 5. Okay, so it can't be simplified any further, so that gives us the value of r. Okay, so that gives us the value of r. So now with having the value of r, is either we can use the distance formula, or what you can do is to calculate just by looking at the y-axis, because now this distance from here to here, you can calculate it by inspection, by looking from here up until here how many units are there, or you can use the distance formula between the two of them. Okay, so just to avoid causing confusion, guys, let's rather use the distance formula. So it's going to say WR is equal to square root of, you know, most x1 minus x2. Yeah, I know, guys, sometimes you can put letters, it really doesn't matter as long as you substitute correctly and you choose your x1 and what, or you can write the letters there. Okay, square root of, come here, let's see. Okay, we can say our x1 there is minus 4, is that 1, and therefore minus into minus 4. This is the one we started with, the one at w, so we can say 4 minus into minus 52 over 5, close bracket, and another close bracket, then everything squared. I forgot to square here. Thank you guys for showing me that. Easy to make mistakes with these ones, eh? All right, therefore you can say, come here and say w will therefore be equal to, based on the calculation on my calculator, guys, I hope you get the same thing, is 72 over 5 units. If you didn't get this 72 over 5 units, please let me know, guys. Maybe I'm the one who made a mistake here. I am Gaston Mapala, so let's continue, move on to 3.5. All right, 3.5, it says calculate the size of theta. Okay, great stuff. So now with this one, when they say calculate the size of theta, we really need to have a look at this one very, very carefully now, so that we fully understand what is happening here. This is where now you're gonna have to apply a little bit of Euclidean geometry rather, so that you fully understand what is happening here. All right, okay, looking at where theta is sitting right there, guys. There is S here, so I would like you to give attention to these 3 coordinates, okay? Because what I'm looking at this triangle right here, okay? I'm looking at this triangle right here. To make life easy for yourself, guys, always, because this is analytical geometry, always focus on the angle that is formed by a line together with the x-axis, okay, which is the angle of inclination. So let's have a look at how many angle of inclination do we have here. We have got, I'm gonna try to mark them here with a different color. Yeah, let me just use red. The angle of inclination we have got this one here, which is beta. Okay, it's what this line here, which is the line of SK, is forming with the x-axis. And then we also have got this one here. It's what the line, this one is formed by line SK. Okay, this one is formed by line, oh, I think I'm about to explain this thing very well, so please pay attention, guys. This one is this angle here is formed by line ST, and we know the gradients of these lines, by the way, okay, because we already did them previously. Please make sure you didn't fast forward this video, because now you would have missed out on the gradients of these lines. Okay, so now with that said, so you see we've got 2 angles. We've got this, you've got this angle here, you've got this angle beta here, you've got this angle here. So now what you want to do, can you see that if you've got this angle here and then you've got this one, there's this angle here. What happens when you've got angles that are like this on a straight line here? this angle is equals to this one. What are they for? Is it corresponding? Okay, yes. So therefore these angles are equal. So therefore even this angle here would be equal to the one that side. Okay, so we already know this one now. I'm just gonna color it with red here so that we know this one here. So therefore once we know this one here, this angle here beta, we can easily know this one because angles on a straight line, they give us 180. So now I am gonna color this one with a different color, yellow rather. So we would know this angle here as well. After knowing beta, we would know this angle here because this angle here is given to us by 180 minus whatever we got there. Okay, so therefore with that said, now theta would therefore be, we're just analyzing here guys, we're not writing anything yet. Therefore theta is going to be, theta to us is going to be given, theta is going to be, is the external angle of, in this triangle here, N. Okay, MS. Theta is the exterior angle of this angle, therefore is going to be angle N, which we got after minusing that beta there, plus angle M is the sum of the internal opposite angles. All right, so now let's go ahead and we are gonna start with the line SK and find beta. Okay, so SK is represented in a red color, so I am gonna write in red here so that you guys can follow. Okay, good stuff. So I'm gonna write in red here. Let's say now S, what is the gradient of line SK? The gradient of line SK as given previously in the previous everything that we did previously, we said that equation SK, it was given by this. If I still recall very well here, SK is given by negative 2 over 5 x minus 12. It was our equation there with that gradient. We know what to do with the gradient that is negative, guys. So we are gonna come here and say the relationship between the gradient, okay, this is what we're busy with, 3.2, okay, is equal to 2 over 2, and then the relationship is symbolized by tan. Okay, so it's going to be tan beta reference because now I have removed the, we have therefore removed this, what do they call it, the negative sign. So we are going to account the negative side when we come this side here, 2 over 5, and then when you put this in our calculator, it will give us a reference angle of, I'm getting 158.190. This is just the reference angle, guys. So therefore okay, no, it's not, is it really? No, yeah, it's the bigger angle. Therefore the actual smaller angle that we need there, the beta, the one that we need there, is going to be given by 180 minus this angle here, so it's going to be 158.190, which gives us a result of 21.80. okay, great stuff. So that's how you get that angle here. So therefore I need to put it in a yellow color rather, because now this is what we got here. Okay, you can see I'm circling it, guys. So it gives us this angle right here. Where are we? So this angle right here we know is going to be 21.81. so now let's come here and calculate this one here. Let's calculate the M now. All right, so let's go to the M. M is sitting on the, is given by the line ST rather. So we are gonna come here and say, okay, ST equation is given by half x plus 6. So our gradient here of ST is given by 0.5, which is going to be equals to tan M, the M there. So therefore it means angle M is going to be given by tan, we are looking for an angle, so it's going to be 0.5, which is therefore angle M is going to be equal to, it's giving me 26.560. I hope you get the same answer, guys. So now with this, now we know this one here it's 26 rather, 26.560. So now having that, now we can easily get theta, like we illustrated earlier, that theta in triangle, can tell the examiner here where you are. You can say in triangle NMS, so that the examiner doesn't get confused, guys. So you can come here and say, all right, so therefore in that triangle, theta is going to be equals to M plus N. Why are we saying that? Because this is the sum of exterior angle of a triangle is equals to the sum of internal opposite, Euclidean geometry. All right, I'm not gonna write it here, guys, because I've already explained this in question 3 of November 2020. I already explained it in question 3 of November 2021. Now we are in 2020, so please make sure that you watch the whole series, so that this concept really delves in your brain, so that you don't forget it and you really practice it thoroughly. All right, so now let's see. M is given by 26.560 plus what do we have here? We have got N is 21.810. Therefore theta is going to be equal to, let me check on my calculator here, it's giving me 48.37. All right, so this is our angle theta here. We managed to get it right, guys. Yeah, so please, guys, you can see that if you stick to the basics, really it will be very difficult for you not to get this one right. So please, guys, please make sure that you fully understand this. If you don't understand, please let me know, and then I will definitely do my best to assist you. Reach out to me on a WhatsApp, then we'll do my best to make sure that we work together to get those distinctions. Okay, let's move right along to question 3.6. 3.6, that let L be a point in the third quadrant such that SWR, let's go here and come and see SWR, and then L is in the third quadrant. So they said maybe L is sitting somewhere here, we don't know, we're about to find out. Okay, there you go. So basically this is what they are asking us. If this is the quadrant there, then they are saying in order, in that order forms a parallelogram, calculate the area of this parallelogram. All right, great stuff. So now guys, on this one, please make sure that you fully read the question and understand. So now let's go and have a look at in triangle SRW. Where is SRW? SRW. So we've got this triangle here. So now they are saying we need to go and look for the H that is perpendicular to this one here. Okay, guys, let me remove this here so that it is easy for you guys to see and understand what we're talking about here. I think these numbers here would really if I leave them here, I'll be causing really injustice to this question that is very critical, because I've seen these questions a lot in an exam. So I'm just gonna remove all these things here that are as much as I can, so that you guys can see what I'm talking about. Okay, so now let's look at this one. They said L is in the third quadrant such that it forms a parallelogram. So let me try my best to draw this one here, a straight line if I could here. There you go. So L is sitting somewhere here, guys. We don't know where it's sitting, but it's fine. Well, the only thing we need here is the area of the parallelogram. Okay, there you go. Wow, great stuff. So I think that's best enough. So guys, you would know that the equation of the area of a parallelogram, I think we should put it here, area of SWRL, the formula is given to us by half base times the perpendicular height. All right, so now we need to find the perpendicular height of this parallelogram. All right, so I would rather mark it from here, okay, because this is the perpendicular height. I think you guys remember this in grade 10, somewhere there in grade 11, where they were saying no, you need to, let me just put this one in dotted line, you need to find the perpendicular height before you can calculate the area of a given shape or anything like that. Okay, so now what we have here, do we know the coordinates of S? Yes, we know the coordinates of S. I think we calculated the coordinates of S on the previous question. Yeah, it was a point of intersection, so I'm just gonna put them here. The coordinates of S is minus 20 is to negative 4. But however, because where it's sitting is also symmetrical to this one here, to this P. So if this point is sitting here, you have got this Y value. It means you also have got this Y value. I'm gonna put P stroke here. So it means we don't know, yeah, we would know the X value here would be negative 4, and therefore also this one would be negative 4 as well. So now, having that, and not negative 4 rather, I think yeah, it is, okay. So now, having that, negative 4 as our coordinate of P stroke here. I hope you guys understand how I got this, because it's symmetrical to this P that is sitting there. Okay, so now with that, we need this length here. We need this length here. This is our perpendicular height. This thing that is here up until this point is the perpendicular height, so we need it. So let me rather say mark it nicely here with a different color. Let me see if I can get a different color. So this here is the perpendicular height, guys. Triangle. And let me just give you a reminder, guys. You remember, you guys did this a lot, man. I think it was there on one of my videos in grade 11 rather, or grade 10 if I'm not mistaken. You had a triangle like this one where you had to come here and find the perpendicular height before you can find. Sometimes you had a triangle like this one, okay, where you had to come here, find this perpendicular height all the time. Okay, so right guys, having said that, this will be the perpendicular height of our triangle here. So now what you can do, instead of doing it the other way around, I just checked now, I found a simpler way of doing it. What you can do, you can say, okay, this triangle here is half of the other one. Sorry, my drawing is not up to scale, but you can calculate the triangle of, you just calculating the area of this triangle here, triangle of triangle SRW, once you have got that perpendicular height, and then the base would be this one here. All right, so now with that said, let's come here and say area, and then after getting this area, you can just say this is area for triangle number 1, and you have got number 2 here. Then you can just multiply by 2, and then it will give you the total area of the parallelogram. All right, so now with that said, let's come here and say, okay, what is our perpendicular height here? Our perpendicular height is going to be given by this distance here between P coordinates and then P stroke here. So now what we can do here, we can come, I know guys, this is becoming a bit messy here. Okay, what we can do here to find the perpendicular height, first we can say, okay, perpendicular height of this triangle here is given by negative 20 minus into minus negative 4 minus is going to give us 16, which is our perpendicular height. Okay, which is our perpendicular height. So therefore, with that said, and then WR would be our base, which was given by 72 from our straight line, 72 over 5. Therefore, the area of this triangle S equals to half base, which is 72 over 5. It's multiplied by times the perpendicular height, which is 16, therefore would give us 115.2. So having this, so therefore the total area of the area of SW, because it's made out of those two triangles that are half, is going to be twice times 115.2, which gives us a total area of 230.4 units squared. Okay, and that's how you deal with a question like this one, guys. I'm sorry, at the end there it got a bit messy because I was a bit confused when it comes to getting the area of the parallelogram, but I managed to figure it out, guys. So please make sure that if you are confused like I was before, please let me know so that we can do this question again, just this one alone, the 3.6 of November 2020, paper 2. And it is what it is, guys. Let me see you on the next upload, where we'll be doing question 4 from November 2020 up until November 2022. I am Gaston Mapala. Make sure that you are subscribed so that you don't miss out on any examples or in any past paper on how to solve them. Remember, I always say a memorandum does not talk, but here at Maths with Gaston, we will explain to you how to deal with this problem in the simplest way as possible to the best of our ability. See you on the next upload.